Hello, my name is Rebecca A, and today I will be presenting a PowerPoint on conic sections, which is my math project. So what are conic sections? Well, we have the different conic sections listed here: hyperbolas, parabolas, ellipses, and circles. Khan Academy founder Salman Khan himself does a wonderful job of explaining the term conic sections in his video Introduction to Conic Sections. Now, we're not going to watch the video right over this video, so I'm just going to paraphrase what he said. These are the different types of conic sections, and you see here a conic section is just a plane intersecting with a cone. So if the plane is parallel to the bottom of the cone, we get a circle. If we tilt that plane a little bit, then we get an ellipse. If we line the plane up with the side of the cone, we get a parabola. And if we extend that parabolic plane, per se, then we get these two parabolas, which actually are both collectively referred to as a hyperbola, one hyperbola. Okay, so what is the definition of a parabola? Well, a parabola is a symmetrical open plane curve formed by the intersection of a cone with a plane parallel to its side. The path of a projectile under the influence of gravity ideally follows a curve of this shape. So here are the different ways to express a parabola in equation. This is the standard form, y equals ax squared plus bx plus c. This can also be referred to as the quadratic formula. If a is greater than 0, then the parabola will open upwards, just like this. Please forgive me for stuttering. And if a is less than 0, then the parabola will open downwards like this. The vertex form is just another way to express a parabolic equation, with h and k being the coordinates of the vertex of the parabola. So the vertex form equation is y equals a times the quantity of x minus h squared plus k. Now we will go to Desmos, where I can show you how these things are the same. So let's put the first equation in, y equals ax squared plus bx plus c. And we see here that we have an upwards opening parabola. If I take a, which is currently greater than 0 now, and I move it to the left and make a -1 right here, then we get a downwards opening parabola, just like I stated before. So let's go back to our presentation. Well, actually, one last thing. We will examine how the vertex equation works. So y equals the quantity of x minus h squared plus k. Please ignore that. So we have the same thing. We have an upwards opening parabola, and a is the same. If we make it negative, then the parabola is going to be downwards. If we make it positive, then it's going to be upwards. H and k are just the x and y coordinates of the vertex. So right here, the vertex is situated at 1, 1. So if we were to change the value of x, then this parabola would be shifted horizontally. If we were to change the value of k, this parabola would be shifted vertically. So it is rather convenient in terms of calculating the vertex of the parabola and movement and things like that. And here, like I said before, this is a standard equation. If a is greater than 0, then the parabola is up. If the a is less than 0, then the parabola opens downwards. And like I said before, here's the vertex, which is either the lowest point on a upwards opening parabola or the highest point at a downwards opening parabola. So we see, like here, lowest point, and right here, highest point. Please pretend that this is a good drawing. Anyway, So what are examples of parabolas in real life? Well, we have roller coasters, the McDonald's logo, of course, and trajectory physics. Now, I don't know if you can see it here or not, but the McDonald's Big M logo is graphed alongside a parabola with an actual graph with numbers and coordinates. But even if you can't see that parabola that's graphed alongside this, you can still see the downward arches of the M. Roller coasters are a good example of parabolas as well. In addition to that, we can see the conversion of potential energy into kinetic energy as the cart moves up, and then downwards. And trajectory physics is just a way to describe the path of an object that is sent into the air. So this is projectile motion. What comes up goes down. I don't think that's how the saying goes, but it's true for trajectory physics. And the next problem that I will be doing comes from YouTube user Jacopo Stefani. Please go subscribe to him and give him all the credit for this following problem. Okay, a toy rocket is launched from a platform and its path can be modeled by the equation h equals negative 5t squared plus 50t plus 2, in which h is the height in meters and t is the time in seconds. The first part of the question asks, what is the height of the platform? Well, for some of you, this answer might be extremely intuitive. For those of you who might not get it right away, what this question is asking is, at what point does the rocket not move such that the overall h value equals the height of the platform? Well, we know that at 0 seconds, the platform is still in contact with the rocket. If the rocket flies upward, then we have no idea how high the platform is. But if we plug in 0 for t, then we can find the height of the platform itself, since the rocket has not yet departed from the platform. So we substitute t with 0, and we find that these first two terms cancel out, and we are left with h equals 2. So the height of the platform is 2 meters high. The second part of the equation is, what is the maximum height reached by the rocket? Well, what this is really saying is, what is the vertex of the downwards parabola formed by the motion of the rocket? So there are two ways to find the vertex of a parabola. One is called completing the square, which is normally taught in any Algebra 2 class. However, it's not a particular favorite of many people. It is not my particular favorite equation or method of solving an equation, rather. But instead, I will use a much simpler way to determine this with the equation is x equals negative b over 2a. Please bear with me, I don't have one of those fancy writing tablets, so everything is just going to be drawn a little slower. Anyway, so if we plug in the value of a and b from this equation, which remember is still in the format of y equals ax squared plus bx plus c. So we find the a and the b values and we take it and plug it into this equation. So negative 50 divided by 2 times negative 5 eventually equals 5, so that we know when the maximum height is attained. It will be 5 seconds, at 5 seconds. So now that we know the x-coordinate of the vertex, all we have to do is plug in the x-coordinate into the equation to solve for the y-coordinate. And if we plug it in right here, you can see that we eventually end up with h equals 127. So the maximum height attained by the rocket is 127 meters. And when will the rocket reach its maximum height? So when it is just the x-coordinate of the vertex that we just determined, so it'll be 5 seconds. And finally, what will be the height of the rocket after 4 seconds? All we have to do now is replace t with 4 in the original equation, and we find that h equals 122. So the rocket will be 122 meters high after 4 seconds. Okay, what is an ellipse? The definition of an ellipse is The set of all points, P, in a plane the sum of whose distances from the two fixed points F1 and F2 is constant. These two fixed points are called the foci, which is plural of focus. The midpoint of the segment connecting the foci is the center of an ellipse. Now, there are two different versions of the standard form to express an ellipse. This one is a horizontal major axis form. This is a vertical major axis form. What it just means is that this equation expresses an ellipse that is lengthwise. This equation expresses an ellipse that is height-wise. So let us go back to Desmos so that we can see for ourselves how this works. No, I don't want to leave the page. Okay. So x squared divided by a squared equals, or plus, y squared divided by b squared equals 1. Now what we actually have here is a circle, which is not what we're looking for, so all we have to do is make sure that the values of a and b are not equal. So if we were to take a and increase it such that it is greater than the value of b, then we get a horizontally lying ellipse. And if we were to take the value of b and increase it such that it is greater than the value of a, then we get a vertical ellipse. And if we switch x with y and y with x, that is just another way to write the opposite of whatever ellipse that you... It's the vertical equation. I'm sorry, I'm kind of at a loss for words, but it is just the other way that the equation can be inverted so that the ellipse can be expressed in both vertical and horizontal directions. I don't think inverted is the right word, but nonetheless, let's move. The center right here is h, k. So the major axis is the longest distance from the center to any point along the ellipse. So here, the major axis is lengthwise. A is greater than B. So therefore, this is a horizontal major axis. And the perpendicular direction here is the distance between the center and the side, which is B. And B is the minor axis since it is less, this one segment is less than this one segment of A. So what are examples of ellipses in real life? Well, footballs are one good example. One of my favorite examples that I'd like to demonstrate right now is the Toyota car logo, which if you look at it, you can actually see 3 ellipses in it. So the first ellipse is the biggest. The second ellipse sort of branches off of the first. And the third ellipse intersects the second ellipse and connects with the first ellipse. Pretend that this is a good drawing. But anyway, the next problem that I'm about to do comes from the textbook Blitzer Algebra and Trigonometry by author Bob Blitzer. A lot of it is going to be written word for word, so all the credit goes to him. I don't own anything. Okay, a semi-elliptical archway over a one-way road has a height of 10 feet and a width of 40 feet. If your truck has a width of 10 feet and a height of 9 feet, will your truck clear the opening of the archway? Now, it's easy to look at this and say, well, it says that the height of the archway is 10 feet and our height of the truck is 9 feet, so of course it's going to fit. Well, remember, we're talking about basically, it's really a parabola, but we can also express it as a semi-elliptical archway. So at the highest point, it will definitely be 10 feet tall, but we don't know if the side of this semi-ellipse will be hit by the side of our truck, because remember, as we travel down the width of our truck, we do not decrease in height. So are we going to hit the corner of the archway? So if the height is 9 feet or less, then we will not be able to clear it and we'll have to take our car to the repair shop. Anyway, we're going to use this equation since this is a horizontally lying semi-ellipse. X squared divided by a squared plus y squared divided by b squared equals 1. Now, since the archway is in total 40 feet wide, but what we're calculating right now is the distance between the center point and the end of the truck. So we don't need the whole distance of the entire archway. We just want to know if in this segment, if the corner hits the archway or not. If we figure out that it hits the archway, of course it's going to hit the archway on the other side too, because the truck is uniformly the same height as it widens. Okay, so x squared divided by 400 plus y squared divided by 100 is 1. And now the edge of the truck corresponds to x equals 5. We find the height of the archway 5 feet away from the center by substituting 5 for x and then solving for y. So we take our elliptical equation that we just shown you before. 5 squared divided by 400 plus y squared divided by 100 equals 1. So we get 25 divided by 400 plus y squared divided by 100 equals 1. And if we calculate, what we do next is, in order to get rid of this denominator so that we can continue and finish finding the value of y, then we need to multiply both sides of the equation by 400, because if we were to only do it one side, then the equation would no longer be accurate. And this is basic rule of algebra. What you must do to one side, you must do to another. Or what you do to one side, you must do to the other. 25 equals 4y squared, I apologize. 25 plus 4y squared equals 400. Forgive me for stuttering. 4y squared equals 375. And if we divide 375 by 4 and calculate the square root of that, we get the value of 9.68. So our truck will be able to pass through. Not by a lot, but it will pass through. Okay, and we move on to the last example in this PowerPoint. Okay, so what is the definition of a hyperbola? Well, if I can look at my notes. Alright, a hyperbola is the set of points in the plane, the difference of whose distances from two fixed points called foci is constant. Perhaps the hyperbola is the most abstract conic section there is. As I showed you before, it looks like two parabolas facing each other vertex-wise. But we know that it's not the case. If we have both of these, then we know that it is just one hyperbola. So the standard form of the hyperbola of the equation for expressing a hyperbola is either the horizontal transverse axis form or the vertical transverse axis form. And transverse axis is just a term that means it is the segment connecting the two foci of a hyperbola. So if we get a horizontal transverse axis hyperbola, let's go to Desmos so that I stop drawing the wrong things. No, I don't want that. Notice how similar the equation of a hyperbola is to an ellipse. We just substitute the addition sign for a subtraction sign. So here we have a horizontal transverse axis ellipse with these curves opening up towards the left and right. Now, if you're me, you might think, it seems strange to look at this graph. It feels like you're not seeing the entire graph. Let's zoom out and find out if there's more information. Well, if we zoom out really, really far, it almost looks as if there are just two lines that intersect that are opposite reciprocals of each other. But we know that this is not the case if we zoom in. So this is basically the basic idea of a hyperbola. And if we want to have a vertical transverse axis, all we need to do is switch y and x. And we find that the curves open upward and downward. Let's go back to the presentation. Just like I said before, this is horizontal, this is vertical. Here we can see the asymptotes that these two curves are following. What is meant by an asymptote is just, it's a point that goes on and on and on and on and on and on and on forever, that the curve will approach, but the curve will never quite overlap with the asymptote. So it is a never-ending approach towards this dotted line. And we have two right here for each hyperbola. We have the foci located horizontally from each other, so therefore it is a horizontal transverse axis. We have the equation here, and we have the equations of the asymptotes as well. And this is the vertical transverse axis. Again, the foci are located this time vertically from each other, so therefore it's a vertical transverse axis. And we replace x from this equation with y, and we still have two asymptotes, and we get the equations of those asymptotes. And again, the curve will approach forever and ever and ever and ever towards the asymptote, but it will never truly overlap. Okay, so what are examples of hyperbolas in real life? Well, it might be harder to find, but basketballs are a very good example of a hyperbola. If you can see the two curves facing inwards, and if you don't have an extremely fancy hourglass, you can kind of see the curves like this. And the last problem that I'm about to do actually comes from a video uploaded by YouTube user Patrick JMT. Please go subscribe to him. He is way cooler than I am and can probably teach you better than I am while I'm muttering and stumbling at the fastest rate I can. But anyway, let's check out Patrick JMT's problem. Okay, so the path of a ship can be described by a hyperbolic model centered at the origin, which is 0, 0, relative to two stations on the shore 168 miles apart that are located at the foci. If the ship is 60 miles south of the center of the hyperbola, find the equation of the hyperbola. Okay, so first we need to find the orientation of the hyperbola. So we need to know if the curves are facing up and down or left and right. Since the only direction that they give us is south, we can safely assume that the hyperbola's transverse axis is vertical and that the equation is going to be y squared divided by a squared minus x squared divided by b squared equals 1. So we know that already. Okay, the ship is located 60 miles south of the origin, which is, again, 0, 0. So we can assume that the ship's coordinate is 0, negative 60, because it is 60 units away south, which is down, from this value. So 0, negative 60 is the vertex of the downwards curve, and the corresponding vertex of the upwards curve is, therefore, 0, 60. So if I can draw that very quickly this is the upwards curve, this is the downwards curve. This is where the ship is actually located at the vertex of this curve, but the corresponding vertex is here. Okay, we also know that the stations are 168 miles apart from each other. So if we divide 168 by 2, it'll tell us the distance between the origin and each individual focus. So what happens when we divide 168 by 2? We get the value 84. And so now we know two pieces of information. We know that C, which is just a constant, equals 84, and A equals 60. So what we are going to do now is we're going to solve for B using the equation C squared equals A squared plus B squared. Yes, I know it's the Pythagorean theorem. It's complicated to prove how this is indeed related to the hyperbola and how hyperbolas have a relationship with this. But anyway, just take my word for it, and we're going to use this equation to solve the problem. So everything now is simple algebra from now on. So we have 84 squared equals 60 squared plus b squared. And we get 756 equals 3600 plus b squared. So now we know 3456 equals b squared. Now we could go further and calculate the value of just b itself, but remember, the only term using b in the equation is b squared, so we already have our answer here. So that we can say the equation for a hyperbola is y squared divided by 3600 minus x squared divided by 3456 equals 1. Thank you for sitting through this and bearing with me as I was muttering and stumbling as fast as I can. I hope you enjoyed this video and learned something from it. Thank you.